Question 1 of this exercise says, verify that the numbers given alongside the cubic polynomials are their zeros. So for example, in the first part, we have this cubic polynomial and three numbers are given alongside. We have to verify that these three numbers are the zeros of this cubic polynomial. Also verify the relationship between the zeros and the coefficients in each case. So what is the relationship between the zeros and the coefficients for a cubic polynomial? Let's write that. So if px is a cubic polynomial, ax cube plus bx square plus cx plus d. So let's say that this is a cubic polynomial, and let's say that the zeros of px are alpha, beta and gamma, which means that p of alpha, p of beta and p of gamma will be 0. Then the sum of the zeros, alpha plus beta plus gamma, so this is the sum s, this should be equal to minus b over a, minus of the coefficient of x square over the coefficient of x cube. The sum of the zeros taken two at a time, which is alpha beta plus beta gamma plus alpha gamma, this should be equal to c over a, the coefficient of x over the coefficient of x cube. And finally the product of the zeros, p, which is alpha, beta, gamma, this should be equal to minus of the constant term, so minus t, over the coefficient of x cube, so minus t over a. So we have to verify whether these three relations hold for each part or not. Okay, so let's do part 1 first. So in part 1, the polynomial is 2x cube plus x square minus 5x plus 2. And the three numbers given to us which we have to verify as its zeros are half, 1 and minus 2. So let's verify p of x for each of these three values. Let's find the value of p of x for each of these values of x. So p of half will be equal to 2 times half cube plus half square minus 5 times half plus 2. So basically I have simply substituted, instead of x I have substituted half. So the first term is 2 into half cube is 1 by 8. So 2 into 1 by 8 is 1 by 4. Then half square is 1 by 4 again. Then we have minus 5 times half, so minus 5 by 2, and then we have plus 2. So 1 by 4 plus 1 by 4 is half, half minus 5 by 2 is minus 2, and minus 2 plus 2 is 0. So p of half is 0, which means that half is a 0 of px. Now let's find p of 1. So p of 1 will be equal to 2 times 1 cube plus 1 square minus 5 times 1 plus 2. So this is equal to 2 into 1 cube is 2, and then we have 1 square, so that's 1, and then we have minus 5 times 1, so that's minus 5, and then we have plus 2. So 2 plus 1 is 3, 3 minus 5 is minus 2, minus 2 plus 2 is 0. So p of 1 is also 0, which means that 1 is also a 0 of px. And then finally let's find p of minus 2. So p of minus 2 will be equal to 2 times minus 2 cube plus minus 2 square minus 5 times minus 2 plus 2. So this is equal to 2 into minus 2 cube is 2 into minus 8 or minus 16, and then we have minus 2 square, so that's plus 4. Then we have minus 5 times minus 2, that's plus 10, and then we have plus 2. So the positive numbers add up to 16, and then we have a minus 16, so the total is again 0. So p of minus 2 is also 0, which means that minus 2 is also a 0 of px. So each of the three numbers given to us is a 0 of px. Now let's confirm the relationship between the zeros and the coefficients. So the zeros of px are alpha, beta, gamma. So let's call them alpha, beta, gamma. These are half, 1 and minus 2. So we have just confirmed that each of these three numbers is a 0 of px. Now let's first find the sum of the zeros. So from the zeros themselves, the sum should be half plus 1 plus minus 2. So this is equal to half plus 1 is equal to 3 by 2. 3 by 2 minus 2 is equal to minus half. So this should be this is the sum of zeros from the zeros themselves, and from the coefficients the sum of the zeros should be equal to minus of the coefficient of x square. So minus of the coefficient of x square by the coefficient of x cube. So that's 2. So from the coefficients the sum of the zeros is minus half again. So both of these match, which means that the sum relationship holds true. Now let's find the sum of the zeros taken 2 at a time, which is t, which is alpha beta. So half into 1 plus beta gamma. So that's 1 into minus 2. And then we have alpha gamma. So that's half into minus 2. So this is equal to, the first term is half. The second term is minus 2. So let's write it down. So half, and then we have minus 2, and then we have minus 1. So half minus 3 or minus 5 by 2. So this is the sum of the zeros taken 2 at a time, calculated from the zeros themselves. And from the coefficients, this should be equal to the coefficient of x, which is minus 5, by the coefficient of x cube, which is 2. So from the coefficients, this should be equal to minus 5 over 2. So both of these match again, which means that the sum of zeros taken 2 at a time, that relationship also holds true. Finally, let's calculate the product of the zeros. So from the zeros themselves, the product should be equal to half into 1 into minus 2. So this should be equal to minus 1. And from the coefficients, the product should be equal to minus of the constant term. So minus of 2. So minus of 2 by the coefficient of x cube. So that's 2. So minus of 2 by 2 or minus 1. So even the product relationship holds true when calculated with using the zeros and using the coefficients. So all the three relationships hold true for the first polynomial. Now let's do the same thing for part 2. In part 2, the polynomial given to us is x cube minus 4x square plus 5x minus 2. So let's assume this polynomial to be px again. So px is x cube minus 4x square plus 5x minus 2, and we have to verify whether the three numbers given to us 2, 1 and 1, whether they are zeros of px or not. So two of these three numbers are identical, 1 and 1. So we just need to check p of 1 only once. So let's do that. So let's first find p of 2. So p of 2 is 2 cube minus 4 times 2 square plus 5 times 2 minus 2. So this is equal to 2 cube is 8. Then 4 times 2 square is 4 times 4, so that's 16, so minus 16. And then we have 5 times 2 is 10, and then we have minus 2. So 8 minus 16 is minus 8 plus 10 is 2, and 2 minus 2 is 0. So p of 2 is 0, which means that 2 is a 0 of px. Now let's find p of 1. So p of 1 is equal to 1 cube minus 4 times 1 square plus 5 times 1 minus 2. So this is equal to 1 minus 4 times 1 square is 4, and then we have plus 5, and then we have minus 2. So 1 minus 4 is minus 3 plus 5 is 2, and then 2 minus 2 is 0 again. So p of 1 is 0, which means that 1 is also a 0 of px. So all the three numbers are zeros of the polynomial. Now let's verify the relationship between the zeros and the coefficients, just like we did in part 1. So let's name the zeros alpha, beta and gamma. So alpha, beta, gamma are 2, 1 and 1 respectively. Now let's find the sum taken 2 at a time, and the product of the zeros using both the zeros themselves as well as the coefficients. So the sum of the zeros, the sum is alpha plus beta plus gamma. This is equal to 2 plus 1 plus 1 or 4. So this value we derive from the zeros themselves, and from the coefficients this should be equal to minus of the coefficient of x square, so minus of minus 4 over the coefficient of x cube. So the coefficient of x cube is 1, so this is equal to 4. So the sum is 4 from both the zeros as well as the coefficients. Now let's find the sum of the zeros taken 2 at a time. So this is t, this is equal to alpha beta plus beta gamma plus alpha gamma. So this will be equal to 2 into 1, so 2 into 1 plus beta gamma will be 1 into 1 plus alpha gamma will be 2 into 1 again. So this is equal to 2 plus 1 plus 2, so that's 5. So from the zeros themselves, the sum of the zeros taken 2 at a time is 5, and from the coefficients this should be equal to the coefficient of x, that's 5, by the coefficient of x cube, that is 1, so this is 5 again. So the sum of the zeros taken 2 at a time also matches. Finally, let's find the product of the zeros. So from the zeros themselves, the product of the zeros should be alpha beta gamma, or 2 into 1 into 1 or 2, and from the coefficients the product of the zeros should be minus of the constant term, so minus of minus 2 by the coefficient of x cube, so that's 1, so this is equal to 2. So even the product matches by calculating using both zeros as well as the coefficients. So all the three relations hold true for the second polynomial as well. And with that, we conclude question 1. To learn more about how QMath can help you crack school and board exams, explore QMath Leap, a live online classroom program run by highly experienced and committed teachers.